Hello students, let us discuss classification of haloalkanes and haloarenes in this video. Let us first classify these on the basis of number of halogen atoms. These are classified as monohaloalkane, dihaloalkane, trihaloalkane. Here, mono words related to single. That means if it have only single halo group, that means X. If it have only single X as shown in here, then it is called as monohaloalkane. And if there are two hydrogen is replaced by 2X, then it is called as dihalo. And if there are three halo group, then it is called as trihaloalkane. You can check the carbon valency of each carbon. You can check that it are tetravalent. Similarly, in the case of haloarenes, if there is only one X, that means a single halo group, then it is called as monohaloarene. And if there are two X, then it is called as dihalo, and if there are 3X, then it is called as trihalo. That means the haloalkanes and haloarenes can be classified on the basis of number of halogen atom. Here we are classifying only on the basis of numbers of halogen atom. Similarly, we have tetrahalo and all. So these are the basic of classification. Next classification, on the basis of compounds containing sp3 carbon X bond. That means here there is a CX bond and that carbon is sp3 carbon. It is further classified as alkyl halides, allylic halides and benzylic halides. Let us discuss each in detail. Alkyl halides is further classified into primary, secondary and tertiary. How we can make a name of haloalkane a primary, secondary, tertiary? Look at the structure. In the first structure, you can find this is a halo group which is attached on this carbon. This carbon is called as alpha carbon. And the neighboring carbon of this, which is present in the alkyl group, that is beta carbon. So, whenever a structure is given to you, find out the alpha carbon and the beta carbon. If there is only one beta carbon in the structure, then we can call it as 1 degree. Or we can say that if there is only one alkyl group which is attached to the carbon on which X is attached, then it is called as 1 degree. Similarly, in 2 degree, there are two alkyl groups. That means there are two beta carbons here. Therefore, it is called as 2 degree. And in tertiary, there are three alkyl group. That means there are three beta carbons. Therefore, it is termed as tertiary. For more clarity, let us take a structure. You have to find out whether this is primary, secondary or tertiary. So let us practice this one. The more focusing area is this X. You have to find it out first where it is attached. The halo group is attached on this carbon atom. So that means that carbon atom is called as alpha carbon atom. That means the group is attached to a carbon. That carbon is alpha. And adjacent of alpha carbon is the beta carbon. And adjacent of beta carbon is the gamma carbon. So when a structure is given to you, first of all mark the alpha, beta and gamma carbons. When you find it in this structure, there is only one beta carbon because there is no further possibility of adjacent carbon of alpha. So there is only one beta carbon. So it comes in the category of 1 degree. Or we can say this whole part can be taken as R. So we can say that there is one alkyl group on the alpha carbon atom. Therefore, it is 1 degree. So you can find it out whether it is 1 degree, 2 degree or 3 degree either by finding out the number of beta carbons or in this way. Let us take one more example. Let us find out the alpha carbon in this structure. So which is our focusing area? X, which is attached on this carbon. Therefore, this is our alpha carbon. As I told you, adjacent carbon, or we can say the neighboring carbon of alpha, is beta. So let us find out where is the beta carbon here. The adjacent carbon of this is this. That is, this is beta, and here this is also a beta. So in this structure, there are 2 beta carbons. Therefore, the structure is, this is 2 degree structure. And in the case of R group, if we want to understand whether it is a 2 degree or not, how you can do? This is the alpha carbon and this group is termed as 1R and this whole group is taken as another R. So we can say that there are 2 R's, therefore it is a 2 degree. Let us take one more example. In this example, this is the alpha carbon. This one is beta because it is adjacent to alpha. This is also beta. There is only 2 possibility here. When you check the structure, there is one more carbon atom which is also adjacent to the alpha carbon. That means this is also beta carbon. So in this structure, there are 3 beta carbons. Adjacent carbon atom means which is directly bonded to that carbon. Why I am taking this as adjacent? Because it is bonded to alpha carbon. So there are 3 beta carbons here. So we can say that it is 3 degree. In the case of alkyl group, when we find this is the alpha carbon. So this group is taken as 1R. This group is taken as another R and this group is also 1R. So there are 3 R's here. Therefore, it is called as 3 degree alkyl halide. The next type is the allylic halides. Allylic halides. Allylic carbons are the carbon atoms bonded to the carbon atom that is doubly bonded to another carbon atom. Here one example is given. This carbon atom is called as allylic carbon. Why it is called as allylic carbon? Because this is bonded. This is actually sp3 hybridized carbon, but it is bonded to sp2 hybridized carbon atom. Such carbon atom is called as allylic carbon atom. That means the carbon atom which is sp3 hybridized and it is bonded to sp2 hybridized carbon atom. That means doubly bonded carbon atom. Then this carbon atom is called as allylic carbon. In this structure, in the second structure also you can find there are allylic carbon. That is, here this carbon is allylic carbon. Why? Because it is sp3 hybridized. How you find out it is sp3? Because all bonds are single here. So it is sp3 hybridized. But the adjacent carbon, this is the adjacent carbon, is actually sp2 hybridized. That means it have double bond there. So it is a allylic carbon. Similarly, this carbon can also be allylic because it is sp3 hybridized, but the adjacent carbon atom is sp2 hybridized. So that is called as allylic carbon. So let us find what is allylic halide with an example. Let us take this example. Here let us find out a carbon atom which is sp3 hybridized. As we have learnt last year about the hybridization, if carbon atom is bonded, all the bonds are single, then it is sp3 hybridized. That means this carbon atom. In this carbon atom, when you find it out, all are single bonds, therefore it is sp3 hybridized. Let us find out this structure, this carbon atom. This carbon atom, there is one single here, one single hydrogen is there, and there is double bond. Because of this double bond, we can say that this is sp2 hybridized. So, allylic carbon, this is an allylic carbon because it is sp3 hybridized and its adjacent carbon is sp2 hybridized. So this carbon is called as allylic carbon, and whenever there is a halogen atom attached to the allylic carbon, then such type of compounds are called as allylic halide. Once again, what is allylic halide? Whenever the halo group is attached to a sp3 hybridized carbon which is attached to sp2 hybridized carbon, then the structure or the compound is called as allylic halide. Let us discuss the next type in the second classification, that is benzylic halide. Here also the bond between the carbon and halo group is sp3 carbon X bond, which is this one. That means the carbon is sp3, this is sp3 carbon and X. But here this carbon is attached to a benzene group. When it is directly attached to the benzene ring, then it is called as benzylic halides. So what is benzylic halide? When the halo group is attached to sp3 hybridized carbon atom which is attached to a benzene ring, then it is called as benzylic halide. Here the name itself relates to benzene. So whenever the word comes benzylic, means you have to remember that there should be a benzene ring, and that benzene is connected to a carbon atom which is sp3 and one X is attached on this carbon, then it is called as benzylic. It is further classified as 1 degree, 2 degree and 3 degree. Just now we have discussed 1 degree, 2 degree in the case of alkyl halides. Here this is halo group is attached to this carbon which is sp3 hybridized carbon and which is further attached to a benzene ring. Why it is called as 1 degree? Because I told you, find out the number of beta carbons, automatically you will get whether it is 1 degree, 2 degree or 3 degree. Which is our alpha carbon here? Because this Cl, that means halo group is attached on this carbon, therefore this is alpha carbon. Find out the adjacent carbon of alpha carbon. Here there is only one carbon atom which is adjacent to alpha, that is beta. What about this carbon? This carbon is not beta, it will be a gamma, and this will be also gamma. So in this structure there is only one beta carbon, therefore it is 1 degree. Let us talk about the second example. Find out the alpha carbon here. Cl is attached on this carbon, this is alpha. Find out the beta, this is the adjacent carbon, this is one is beta and this is also beta. So in this structure there are 2 beta carbon, therefore it is secondary. In the third structure, this is the alpha carbon. This one is the beta, adjacent to alpha is beta. This one is also beta and this one is also beta. So that means here 3 beta carbons are there, or we can say 3 groups are there. Therefore it is called as tertiary. So we have further classified the benzylic halide into primary, secondary and tertiary. Now let us talk about the next classification, that is classification on the basis of compounds containing sp2 carbon X bond. In the previous case, we have discussed about sp3 carbon and X. That means there is a linkage X link with the carbon, that is sp3X. Here it is sp2 carbon X linkage. It is further classified as vinylic and aryl halide. Vinylic halide, when the halo group is attached to sp2 hybridized carbon. This is sp2 hybridized carbon. Why? Because this carbon atom is bonded by double bond. So when you check here, there is a double bond here. So we can say that such type of halide is called as vinylic. In the second case also, when you check, the X is attached on this carbon, and when you check, this carbon atom is actually double bonded. So this is sp2 hybridized carbon. Such category is called as vinylic. Vinylic means X halo group is attached on sp2 hybridized carbon. That means the carbon atom which is doubly bonded. Such type of a compound is called as vinylic halide. If you remember, in the polymers we have discussed a polymer, polyvinyl chloride, in which we have written a formula for vinyl chloride. In that you can find out the chloro group is attached to sp2 hybridized carbon. The next one is aryl halides. Aryl halides, here aryl relates to benzene ring. That means in this also the X, or we can say halo group, is attached to sp2 hybridized carbon, but that sp2 hybridized carbon is actually a part of benzene ring. You can check this carbon atom, which is sp2 hybridized carbon atom. Actually this is one of the carbon atom of the benzene ring. In such case it is called as aryl halides. Let us talk about this example. In this example, halo group is attached to this carbon atom. This carbon atom is sp2 hybridized, and this carbon atom is a part of benzene ring. Therefore, it is called as aryl halide. So let us summarize the classification of haloalkanes and haloarenes as we have discussed in this video. The first, we have classified on the basis of number of halogen atoms. These are, that is monohalo, dihalo, trihalo, alkane. On the basis of the compounds contain sp3 hybridized carbon and X bond, it is classified as alkyl halide, allylic halide, benzylic halide. And on the basis of compounds containing sp2 carbon X bond, it is vinylic and aryl halide. So this is all we have learnt about the classification of haloalkane and haloarene. In the next video, we'll be discussing about the details of these type of compounds. Thank you everyone.